Okay, I'm very happy to introduce Christie Gerrard, who is the Manager for Geoscience Information and Delivery, Geological Survey of South Australia. So Christie is currently working in the GSSA, and she has gained more than 20 years' experience in the mining and government sectors with a focus on leadership and driving transformational digital strategies. Christie's technical skills were gained at Flinders Uni with the Bachelor of Science in Geology and Hydrogeology, and has worked across the industry, including Hill 50 Gold as a geologist in WA. And during this time, she moved from mining operations to exploration, shifting her focus to geological data management and GIS mapping. So Christie also co-founded Data at a Touch and worked as a consultant with various mining and exploration companies from Western Australia across to South Australia, developing geoscience data solutions. Since 2009, Christie has been providing her practical experience and passion for geological data, application development, service platforms, team collaboration and stakeholder engagement within the South Australian Government, and has enabled IT innovation to deliver high quality geoscientific data, products and tools for mineral exploration. So please join me in welcoming Christie to the stage.
Okay, welcome everyone. So I know Bronwyn and Rebecca have also touched on our new department and our future state. So I just wanted to say that I'm really excited that we've got a new geoscience information and delivery team, and that we're bringing all of the geoscience from minerals and petroleum into one group. The new team, we're going to have three main functions. So we have the mineral information function, which will look after, I suppose, the data in, data out from the Mining Act, which Peter Buxton's going to be heading up. And then we have the Petroleum and Geophysics Information team, and that's where Alan Sampson's going to be leading that team. And we're looking after the Petroleum and Geothermal Act data in, data out. And also we have a new function that I'm really, really excited that we've got back into the survey. We were talking about this yesterday, and we don't think we've had a core function around our geospatial and our publications probably since people were talking about an old drafting team. So it's really, really good that we have that function, that we can move forward with delivering our information in new ways. We also are looking to build in our team, our business intelligence capability when we talk about data science, machine learning. And we have this year, just recently, filled a new position for the survey, a new data scientist, Alex Zhu. So he's joined the survey, and we're really excited to see what we can do in the coming year with Alex. So I'm going to be going over a few things that Bronwyn sort of pointed out today. One is the Gawler phase, two, because obviously this project has finished this year, so we're really excited about all the information and data that's coming out. So as Bronwyn said, the Explore Challenge was a global challenge that was held in 2020 in collaboration with Unearth to identify and predict an area of potential of mineralisation within the Gawler Craton in South Australia. The competition attracted over 2,200 participants from 90 countries, and we ended up with 59 quality submissions from 23 countries. We learnt so much about our data and how we delivered our data. We learnt that the data pipelines are really, really crucial, and that geoscience expertise are really fundamental for that validation and ground truthing algorithms and data models. What we're learning as we move forward in the machine learning data science is, and I've seen in the survey, the things that we're working on now is when the geologists, the data teams, we're all working together, but not just working together, we're learning each other's disciplines, and when we do that we seem to be really more successful in what we're doing. We learned a lot about, again, how our data was used and what we can do to improve our data delivery, data quality, and geoscience. And that geoscience can be really, really complex, and we need data descriptions. We need for people to understand our jargon and what we're saying. We learnt that ground truthing products was really, really vital for validation of machine learning and products, and the filling in those data gaps would improve the data science models. The Gawler Challenge recommendations, obviously it led to the Gawler Phase 2, as Bronwyn noted. With a focus around the Gawler Craton area of the state, a large data acquisition program was formed to fill in those data gaps and to gain more geological knowledge and insights into the area. It included a whole sweep of new geophysics data, such as gravity, MT, the EM, the survey that was done by Geoscience Australia Explore for the Future program, and an extensive review and discovery of key drill holes at the core library were resampled, logged, and scanned. And a large legacy data program was included, where we expanded the digital footprint of those hard copy reports, making new data accessible that were previously locked in old document formats. And I know yesterday we put out some new data release in SARIG around the MT data, and I know Peter Buxton's going to go through that later today, and Stefan's obviously going to talk about all of those insights in his session later on today. So a bit on the legacy data. I mean, legacy data, it is gold, and it takes considerable effort to be made accessible. And the GP2 Project Legacy Data Program consisted of GSSA members working with students and graduates to work through all of the company reports, and they really made significant amounts of data available. The stats are just amazing, and I'm going to read a couple out. So this project, there was 10,000 new drill holes, lithology from over 16,000 drill holes, which is really over 1,000 kilometres of log core. 2,058,000 drill holes sampled with new geochemical analysis available, 75 surface samples, and 2,000 petrophysical logs, which are all available in SARIG today. A staggering amount of effort and cost if drilled today. And as you can see here, here's a close-up of the GP2 area that I know Liliana is going to talk about later today, but you can really see the gaps are starting to fill. So there's a question that I get asked a lot, and when we're working through our digital strategy, and I talk a lot about we're creating new APIs, new services, and this is the new way that people want to consume our data. But what is an API? So realistically, it is just an application programming interface. It is a way for two computers to talk to each other. It is a way when we talk about machine to machine, and this is where we're trying to move through in our digital strategy. We have three main sort of APIs that we work in and deliver from the survey. The first one is a WMS, so it's a web map service. So basically what this is, it's generally a base map. So you can put a map on you can sort of put a map and you can identify the points, but you cannot change colours or anything like that. It just acts sort of like a base map. And then you have a web feature service, which is, again, it's a service, it's a geographical service, so you can pull in like the tenement data or our MinDep data, but this is where all the data comes onto your machine. So this is where you can use all the data that's coming through, not just to display on a map, but you can use it in other ways for other applications, and again, when we talk about that machine learning. We also have another one that we're working on. It's called the GSIML web service. So this is a web feature service. It's a complex service, so you can have basic drill hole data to more geological complexity. And currently we've got Ursula Michaels that works on our GSIML. And really, South Australia, we are the most advanced in this service. Currently, we have available for all of our states drill holes. So when you think about that, it's 140 years of data. You can draw in from code all of our drill holes with stratigraphy, lithology, and petrophysical data. And currently now Ursula's working on the geochemistry. So why I'm talking about an API, I kind of want to touch on, we saw this slide with Bronwyn, and obviously this is what we talk about. This project will deliver human readable data. You will be able to go into SARIG as you do now. You'll be able to pull up 15 slices of the new geology with more rich attribution. But you also will be able to, and this is the next slide, is I want to kind of expand on, is you will be able to utilise the API. This project is not just delivering a traditional map. Through API request, you'll be able to access extensive geological attribution and knowledge that cannot be drawn on a map, but you can use it as with machine learning and new models to form new geological insights. As you can see from the cartoon, an API, it really just acts as a waiter. You can take that request back to the server and deliver a requested order. And when you put the effort to standardising stratigraphy across multiple data sets, you can start to request a 3-course meal of geology. For example, you have located a stratigraphy unit of interest and you'll be able to request further information about that strat unit. So here you go, you'll be able to get a return with all of that information behind. The Discovery Mapping Project is not just describing the stratigraphy, it's doing events, provinces, and I've been told realistically you're getting 4 tables back of attribution. Next you can say, well, now I want to know what to return all of the drill holes within that stratigraphy. And then you can call a complex API request and it will bring back all of those drill holes that have hit that stratigraphy. And then again, I can ask another question and go, well, now I want to know, in another time slice of geology, where all of that stratigraphy exists. So here you can come back and forth, and basically what we have here is 3 data sources, 3 APIs, all connected through standard terms, codes and definitions, and the ability for geoscience to be fully open and interoperable. So a bit about SARIG and the vision that we have with SARIG at the moment. SARIG is comprised of 3 main platforms. As you know, we have the SARIG map, and everyone probably here is quite familiar with the SARIG map, but what we're going to do is we're going to expand the SARIG terminology. So we're going to have 3 main platforms, the SARIG map, SARIG Explore, and the SARIG catalogue. Each will hold its own unique functionality to deliver geoscience, information and insights, but all platforms will work seamlessly together and work as one data delivery ecosystem. So here you have the SARIG map. It provides statewide access to our spatial data sets with over 700 spatial map layers, covering map themes from mineral and energy resources, renewable energy and storage, land, water to infrastructure. The SARIG map uses its spatial tools, linking data attributes to geoscience data sources for seamless data mining into rich data sources. It accesses the state's drilling and rock sample coverage and high-quality core photography, along with the original company reports that can all be found through the mapping interface. I know Peter Buxton's going to talk later on all of our great new releases we've had this year on SARIG, so I'd watch out for that talk coming up. SARIG Explore is where we're looking on how we can create visualisation tools for a focused topic of interest. It is where we will take data that is already published via SARIG's open web services to create new interactive tools for explorers or investors. Here you've got the South Australian mining projects and mining activities dashboard that showcases the pipeline of South Australia's mining projects from advanced exploration to operating. The dashboard not only displays the state's state of play in an interactive way, but it also showcases what can be developed from government open web services, providing the ability to connect, innovate and create new insights. We're also releasing today is our new South Australian Critical Minerals dashboard that is going to focus on delivering data from our MinDep database, displaying the state's deposits, resource and reserves, including the status of each critical mineral. In true business intelligence, you can interactively filter and drill down to commodities of interest. All critical mineral data is available, as you see on the dashboard, is already available through SARIG's APIs or traditional spatial download formats from SARIG. Along with the critical minerals dashboard, the survey has also released a dashboard for the mine waste ranking result, where we have taken the results from the mine waste assessment report and visualised in a new interactive dashboard. You can zoom in to a deposit, customise the ranking criteria, access links to MinDep for further information about deposit locations, commodities and history. We're currently rebuilding the SARIG catalogue and looking to be released early next year. Our vision is to combine all of our data and metadata into one catalogue system. For the first time, a user will have the ability to search across all of our data and publications in one catalogue. All metadata from the online shop, publications, reports, data packages, maps, models, spatial data have been mapped to an international standard. The SARIG catalogue is an Azure cloud project which will allow that easier transfer of high volume data. The catalogue itself will be accessible by a CSW, which is a catalogue service for the web, which will allow, via an API, access to all of that information. As part of the project, all of the validation lists have been mapped into new control lists. These lists will be published by a new SARIG vocabulary service, which will be released along with the catalogue. So when we think back to the analogy of the API as a waiter, the new vocabulary service will act like your menu, so you will know what you can order. So as Rebecca noted before, the South Australian SARIG, we are the one window to geoscience information, and we did score #1 in the access to geological databases category in the 2022 Fraser Institute Mining Survey. And we are starting to gather some really, really good international notice and positive feedback, and which is just fantastic. So I really feel like we are moving in a really good direction. So the digital strategy. So at the survey, we want to provide an overarching 5-year digital strategy to drive transformation on how we capture, deliver, and interrogate all of our projects. We want to ensure we are delivering projects and platforms that can integrate further in exploration technologies such as machine learning, artificial intelligence, and big data analytics. And the foundations we build now can continue to deliver emerging technologies, such as future mineral modelling, new exploration methods, and data integration tools. The strategy's main objectives are to build strength and understanding in these emerging technologies, to fill those gaps across the state with legacy data programs, new pre-competitive data acquisitions, and ultimately we want to raise the survey's fair data principle ranking to ensure that South Australia's geoscience data is easy to find, access, formatted for seamless transfer for data decision-making that can drive exploration and discovery. It is future-proofing our data and systems as we innovate across past and prepare for future data collections. We can make sure that we have the right tools for the future. So just to wrap up, I know Anna's just by my side, what our takeaway messages or what's next is the Geological Survey, we are open for business. We really want to collaborate, test and grow our digital potential. Interoperability, it takes time. It takes time to map, it takes time to bring all of those codes and descriptions together, and sometimes it just has to be done manually. But when we do get it right, the ability to share data for application use only takes imagination and innovation. The survey is looking ahead to unlock the possibilities of the state's core library, where digital technologies now give us the opportunity to take a look at our geological data or information with new insights. I think that's me done. Thank you. Thanks.